So hello friends, welcome back. In this video we are going to see Hardcoded Beginner Contest 186. So we will see each of these like problem A, B, C and D. Starting with problem A, it's pretty simple. It says that we have uh, trucks which can uh, carry at most n kgs. The weight of one brick is this. So how much such bricks we can carry? So it's simple that if we have n in kgs and the weight of one brick is nothing but this, so how many such bricks can be possible? It's just n by w, and we need to have a floor value. So basically we will output n by w, so it's basically n by w. So moving on to the next question, which is B. So the problem B says that basically I'm having a grid which H horizontal rows and these number of columns. What it says is the square. Basically, the problem that at every A of ij represents the number of blocks at that location, right? So now it asks me that I have this and this as a matrix, and it represents the number of blocks at that location. So at least how many blocks I must remove to make all the squares equal to like same. So we need to remove the minimum number of squares. At least how many squares, right? Minimum number of squares we need to remove, or you can see the blocks. So as we know that by the first example, I have 2, 2, 3, 3, 2, and 2. So it represents two blocks are at the first location, and we need to make each of these equal, and we can only reduce. So what we can try to do, we can make this whole matrix as nothing but 2, 2, 2, 2, 2, 2. Basically we will try to make it minimum to the, basically we will bring every of a of ij to the minimum value of this whole matrix, and the minimum value of the whole matrix is nothing but 2. So we'll try to bring every number to 2, right? So it is very simple that we will firstly find what is the minimum value, then we will simply iterate on this whole matrix again and check, okay, I need to reduce this 3 to 2, so I need to reduce one block, so 1 is added to my answer. Then for this 3 I also need to reduce this to 2, so 1 is also added to my answer. In total, after moving to the whole block, I will have 2 as my answer, which is 1 from here and 1 from here, right? So you can clearly see that what we are doing is, firstly, in one iteration I am finding the minimum value of this whole matrix and then subtracting that minimum value from every value and having it sum, right? So although basically I did a bit complicated solution, but yeah, you can simply write it very simply that first finding the minimum value, which is the min, as you can see on the screen. Then basically what I did was I basically counted what is the minimum number of values in this, which is 4, and I've basically find the sum of the whole array matrix, sorry. And then I checked, okay, what's the minimum value, and then I subtracted from the sum so as to find, okay, what's the net reduced I will have. But it's pretty, not a good. The basic thing which you can do is just find the minimum, as you know that the minimum from here, sorry, minimum right here, just iterate on this whole matrix again and subtract every element from this minimum one, and the result which you will get, add it in your answer, right? So basically what you can do, just write it here that basically if your answer is sum, basically if it's answer, then you can just do sorry, answer plus is equals to that element which is a of ij minus that minimum value, right? And you can simply print your answer in this place, answer, you would be good to go. So yeah, basically you can do this, and it's also, like, it's good. So yeah, you can do like this as well, and as I showed you that I took the whole sum, or you can do like that as well. Now moving on to the problem C, it's also pretty simple. It says that there's a person and he hates the number 7, right? So what we want is that in the representation of in these two forms, uh, we don't need the number 7. So basically how many such numbers between 1 and n both inclusive are possible. So it's basically greedy. Sorry, it's basically implementation based, that we will iterate from every number from 1 to n, right? And then what we will do is that we will check, okay, do suppose if the number is I in the between, so I will check if the ith number, which means that the number I, uh, let me erase this. So I will just check that if the number I, and I will find its representation in both the forms, which means the decimal form and the octal form, and I will check that in its representation in this form is the number 7 occurring. If it is occurring, then I will simply return like value as a flag as 1, and I will not add it in my increment as my answer. And if it will not contain 1, so I will add that number in my answer, which means that I will add 1 in my answer, because I have found a number which has no 7 in both of these forms, which means that neither in the octal and neither in this form. So now it's pretty simple that how we find the octal numbers and how we find the decimal numbers. Like, it's pretty standard. What we do that for every number we divide by the number 10 to find that number, and here if we do by 8. Let me show you the code. You will be get good intuition by that. So here FD indicates, first of all, let me bring to the, first of all I input my n, then I simply iterated on my whole numbers from 1 to n, and I had my answer. Answer indicates basically, okay, how many number of numbers are there which will follow this condition. Now basically I check that FD and FO. Basically, FO means that a flag for the octal at any step. If it has a 7, so my flag will be 1. I will return basically 1. I will show you about what I am returning. And if it is 1, then I don't need to add it in my answer, either for FO or FD. But if it is not, then I will add 1. Basically, I am adding 1 here. So what I am doing is that I will simply, basically it's FO. So basically, how we can check is that if I have a number, suppose, where's the number? Where's, yeah. So this number is this, right? So you can see that it says that firstly for decimal you are pretty sure that for every number I, let's suppose the number is 17. So I will extract the last number, which is 7. If it is like any of this becomes 7, then I need to return 1 because I have found a 7. If I found any number which means the value as 7, then I need to return a 1. And basically 1 indicates that I don't need to include it in my answer, which means that I don't need to increment my answer. So basically, as you can clearly see, that I am doing mod by 8, because as I said that for octal I do mod by 8, and it's simple that in decimal we do mod by 10. So I'm doing it pretty simple until my n is exhausted, because I need to check for every digit. And then for n equal to, then I check that if n equal to 1, then okay, sorry, my number is not good, I need to return 1. Basically 1 indicates that okay, the number is not good and I don't need to add in my answer. And thus I do it for O and D, and yeah, you are good to go. So it's basically the brute force thing. Now moving on to the next problem, which is the problem D. So problem D indicates, basically says that, let me put whiteboard. So it says that we have n numbers which are a1, a2 up to an, and what we need to find out is that for every number this a1, I need to do a modulus subtraction with every number which is after it, right? Like suppose for the number a2, I will do modulus subtraction of every number after this number, right? Okay, fine. So basically it says that, okay, what's the total sum of all this, which means that a1 minus a2 mod, a1 minus a3 mod, and so on and so forth up to a1 minus an mod. Then a2 minus an mod plus a2 minus, sorry, a2 minus a3 mod, a2 minus a4 mod, up to so on. So basically I am having a number a1, then I am subtracting the modulus subtraction with every other numbers which are after it. So basically, if you will try to brute force it, so it will take O of n square, because for every number, if you do the modulus subtraction with the every other number which is next to it, then it will take O of n square time, which is not good to us. So we need to find out a strategy. Now, basically, let us see the strategy by an example. So basically, it says that first example, when my n is 3, my elements are 5, 1, and 2. So basically, it is saying that I need to do 5 minus 1, right, mod, plus 5 minus 2 mod. Now moving on to the next element, I will do 1 minus 2 mod. Basically, I'm adding it, and then at last I am on 2, and there's no further elements after it, so I don't need to do anything. So the first thing which comes in my mind is, okay, I am doing for every next element. So by anyhow, if I can do for every element, which means that I was doing 5 minus 1, right? 5 minus 2, right? Now I was doing 1 minus 2, right? 1 minus 2, right? Now, because I was only going forward, let's move backward also. So what I will do, I will do, let me, sorry, yeah. So what I will also do, I will, let me write it with blue. So what I will do, I will do 1 minus 5, although it is not required, but still I am doing it. I will show you why. Now when I'm on the next element, so after it there is no such element, but still I am doing afterwards. Sorry, there is no such element, so I'm not doing afterwards, but before it has. So I will also do with before, which will be nothing but 2 minus 5 and 2 minus 1. So you can clearly see that the number right here and the number right here, these are equal, because actually I am doing, here I am doing a minus b mod, and here I am doing b minus a mod, and we all know that a minus b mod and b minus a mod both are equal. Very fine. You can also see that 5 minus 2 and this number is also same. Very fine. And now you can also see that 1 minus 2 and this number, it's also same. So you can clearly see that if I, firstly it was said that I only need to do mod from starting one to the next elements which are after it. But if I think logically, and if I say that, okay, if I do the mod with every element of this array, then I will think that, okay, my value which I wanted in the final, it is repeating, which means that I wanted the sum right here, right? But actually I'm obtaining the same sum again because of the left part, because earlier it was said that I need to find for the right part. Now I'm finding for the left part also. So basically left and right. So basically my answer which I will get, the whole answer, I need to do half of that. So I will get my, basically the answer which I wanted. So now I'm sure that, okay, what I will do, I will find the answer for the whole and I will half it so as to get the answer for the right part only, which means that I'm moving only right. Okay, very fine. Now my final strategy, aim is that I need to find the answer for the whole. Now it's pretty simple and standard problem, which is reduced that if I have this array 5, 1, 2 and I need to find all these values, so it's very simple that in O of n I need to find. And I know that for mod, what I wanted is that at any step, I should know that how many elements are smaller than it, how many elements are more than it, what is the sum of the elements which are smaller than it, what is the sum of the elements which are more than it, right? So if I wanted that how many elements are smaller than it, I wanted to how, what is the sum of it, how many elements are smaller, which means that for ith element I should know that how many elements are smaller in this array. I can simply sort it. So what I will do is that I will simply sort this array, which means I will make it 1 to 5. Now for the ith element, right, what I will do, I will maintain a prefix sum, right, which is this. Now first of all I will have the sum of this whole array, which is sum, right? It is nothing but 5 plus 2 plus 1, which is 8. So it is the sum, right? Then I will have a prefix sum, which means the left sum. So at every step I will have the left sum. Now if I subtract the left sum from this, so I will have the right sum, which means that if by let us suppose that if I have this left sum, right? So left sum is nothing but, left is for this, let me erase this, left is this, right? And remaining will be nothing but sum minus left, right? I know that my indexing is 1 base. So if it is I1, I2, I3, so in total I know my n is 3, right? Pretty fine. So number of elements which are less than or equal to the AI are nothing but 2, which is this. So I'm pretty sure that at first step I know my left sum, which is 1 plus 2, because basically what I will do is that I will find the left sum at every I. So when I am reaching a of I will just add my a of I in my left, which is the last left, and I will get the new left. So with that new left, I can find the new right, and right is nothing but sum, which is the whole sum, which is 8 minus the left part, which is this. So 8 minus 3, which is nothing but 5. So my right is nothing but 5. So my left is 3, my right is 5. Now what I need to find is my mod. Now what I am doing is basically I know that all the numbers which are before that ith element, which is 2, are smaller, and after that are more than it. So basically what I will do is I will ultimately find the value of this, right? And then after that I will find the value of this. So basically here I am subtracting. Now I can simply remove the mod, right? I can simply remove this mod. Why I'm removing the mod? Because I clearly know that as I write it down, so the element a of I is more than I, the element which are like I minus 1, I minus 2, and so on. So these are all smaller. So I can simply remove the mod. Now you can clearly see that my 2 is the my ith element. So basically how many occurrence of this 2 is the index, which is 2. Index is 2, right? So I can clearly say that number of elements including that ith element are nothing but I. So I can simply write my I into a of I minus, I can simply write 1 plus 2, because simply I am subtracting. Basically I is the occurrence of these two. The 2 is here a of I minus the this. Let me erase this. Yeah, it is basically this. So what is this? It's the left sum minus left. And what is the right part, which means that for the answer for the right part, it is nothing but uh, the right sum, which is right, minus how many number of elements after that are nothing but n minus I, because you can clearly see that if my n was 3 and my I was 2, so number of elements after that ith element are nothing but n minus I. So n minus I into that ith element, which is a of I, right? So by this I can find the answer of this whole thing, which means that for the ith element I am doing the mod. So I can find for the ith element I'm doing the mod, I can find this value in O of 1 by this, right? So if I can find this in O of 1, so I can simply iterate on my whole array, right? And I can find it for every number. I will add this in my sum, and at last, basically, sorry, I will add this in my answer, and basically at last I will do my answer by 2, right? So basically you can clearly see that I was pretty sure that my uh, ith element is more than all the left elements. Here I'm pretty sure that my ith elements is less than all the right elements. Left is the sum of all the left elements including the ith element. Right is nothing but the sum of all the elements after the ith element, right? So with this I am finding the modulus of all the subtractions of that number with all the other numbers in O of 1 for that particular element, and I will do it for every element. So let me show you the code. It's pretty simple, the same thing which I showed you here. Sorry. So basically you can see that I had my n, basically input, and then I input my array. It's the sum of all the elements. As I said that I need to find the sum, because basically I will compute my left and right, I will compute by subtracting from the sum, right? Then I said I will sort it, because by sorting I will be pretty sure that all the elements left are smaller, all the elements right are more. So basically my answer is the final answer, which I need to by 2 in the last. My last is nothing but my left sum. I will store it in my last. So my left will be nothing but my last plus a of I, because starting at starting my last is 0, because I'm updating my last by left, right, in the end. Then my right is nothing but, as I said, my sum minus left, because in total my left plus right is equals to sum, right? So my right is nothing but sum minus left. Then as I said that I will do my I into a of I minus left, which is this I into a of I minus left, then plus right minus n minus I into a of I, which is right minus n minus I into a of I. Then sorry, then where's the code? Then I will just simply print my answer by 2, because the answer I obtained was for the all the lefts and all the rights, but actually I wanted for all the rights only. So yeah, it's all for this video. In the next video we would be seeing E and probably F. So yeah, see you in the next video. Until then, be happy coding. Bye.